Hello students, today we will discuss about liquid waste management, a part of waste management as well as the application of composting. I will talk about types and sources of liquid waste, characteristics of liquid waste management, liquid waste treatment as well as water resource management and application. So waste can be non-solid. Sometimes for disposal purpose, some solid waste can be transformed to the liquid waste. The liquid waste, the discharge can come out from the point source as well as non-point source. According to WHO, World Health Organization, the sanitation means provision or facilities or the services for the safe disposal of human urine and feces. So that is nothing but liquid waste management.
Ma'am, what is point source and non-point source discharge?
Point source discharge is coming out from the industrial effluent and non-point source discharge is coming out from the agricultural runoff. Terminology, effluent. So that means the wastewater discharging from the pipe, and very highly contaminated water is called the leachate. You know the liquid waste can be natural or can be man-made. Type, source, composition of the liquid waste. So any type of water, wastewater, if it is adversely affected by the anthropogenic influence, so it is termed as the wastewater. Municipal wastewater, it is the combined sewer of storm sewer and sanitary sewer, and it is taken for the treatment. After treatment, it can be discharged, and centralized sewer system will rely upon the on-site sewage facilities. Sewage, sullage, runoff and industrial water. Sewage and sullage, they can be generated from the schools, from institutions, from households. And industrial waste can be generated from different industries. Their content, their type can be varied. They may contain some hazardous or toxic waste which needs the special treatment. Runoff, they can be generated from the rainwater or flood. And liquid waste can also be generated from healthcare facilities. Sewage. Sewage is nothing but the contaminated water with human feces and urine, that is termed as black water. This sewage includes domestic, municipal and industrial wastewater. Now what is sewerage? It is the physical infrastructure including pipes, pumps, screens, channels, etc. which convey the sewage from the household and make the sewerage network, ultimately convey them to the treatment plants or for the disposal from the origin to the treatment. Now sources, it includes the human waste like urine, so that's why it is called black water. Septic tank discharge, the discharge from the sewage treatment plant as well as groundwater infiltration, seawater ingress, river water ingress, storm drain, highway runoff as well as agricultural runoff. It contains some sort of oil and natural gas, toxic contamination, extreme pH waste as well as it contains organic and biodegradable materials. Composition, greater than 95% is water. Right? It contains pathogenic bacteria, viruses, protozoa as well as non-pathogenic bacteria. Otherwise, it contains some soluble, organic and insoluble organic particles as well as inorganic soluble and insoluble particles. It contains gases like H2S, carbon dioxide, methane. It contains emulsion from the paints as well as macrosolids. It contains some of the toxins such as pesticide, herbicides, pharmaceuticals, hormones as well as it contains protozoa and other parasites. Sullage. Sullage is nothing but grey water. It is generated from personal use. So source include the floors, the clothes as well as dishes. So we are actually oftenly throwing them off. And composition includes soap, detergent, toothpaste, cooking oils as well as it contains hair, total suspended solid, coliforms, nitrogen and phosphorus. Runoff. Runoff is generated from the flood water, okay, from the rainwater, as well as it can release from the dam or ponds, fine. And in case of town, you can find the storm water canal, right, which convey the drainage, which convey this runoff. And composition includes stick, heavy metal, soil particles, etc. Industrial wastewater, the effluent generated from the different industries. The sources includes the industrial waste, industrial cooling water, industrial processing water, industrial site drainage. And composition, different industry wastewater contain different thing. Like dairy industry contains oil, fats, etc. In case of wine industries, contains volatile organic carbon, sugar. In case of tannery waste, tannery industry waste, it contains hair, hide, sulfite, etc. Characteristics of liquid waste with respect to indicator as well as parameter. Liquid waste quality indicator. Any oxidizable material present in water can be oxidized biochemically by bacteria as well as chemically. The reaction includes oxidizable material plus bacteria, nutrient plus oxygen. They may give rise to carbon dioxide, water, energy as well as other oxidized product. Apart from which the sulfur can be oxidized to sulfate as well as nitrite can also be oxidized to nitrate. Parameters: 5 days BOD, biological or biochemical oxygen demand, 4 hours COD, chemical oxygen demand, as well as pH, total suspended solid, ammonia, nitrate, they can be taken as parameters. Liquid waste management. I will talk about definition, significance, parameters and characterization. First, management of liquid waste. So it is a way to dispose of the waste, the liquid waste, so that will be safe for the human and environment. So this is disposal management. Significance. So the main significance is that you must know there is the interlinkage in between water and the energy and independent as well. So water scarcity is getting increased, fine. So we need the shortage, we have to increase the demand for the fresh water. So we have to protect them off because water is universal solvent. So it needs the water engineering as well as water demand for the irrigation as well as the water resource utilization is still present. So sustainable water supply needs adequate quality for the future availability as well. Next one, general principle. So there must be some principles. So that involves the user decision making, right? As well as local community based technologies. Then sustainability as well as integration of the supply and the hygiene. It includes the energy and resource recovery as well as biochemical or biological technique including aerobic and anaerobic facility. So waste handling and transport, waste minimization, everything is included here. Central principle, waste hierarchy. 3 R's are there: reduce, reuse and recycle, as well as very important point, the life cycle of a product, right? That is manufacture and distribution of all those 3 R's. Then very important point is resource efficiency for economic and global growth, as well as polluter pay to the principle. If it creates the negative impact, it must be paid by the polluter. Characterization of the human waste management, sullage management, runoff management and industrial wastewater management. First, human waste management. You have to be conscious that must not contaminate the groundwater as well as surface water. Excreta must not be available, must not be exposed or accessible. No odor will be produced. So a particular system will be made so that can be construction and operation is so simple and that can be lasted for at least 5 years. Okay, so according to the cost effectiveness. Sullage treatment. So we will not directly throw the cooking and washing water. There are so many different collection and disposal techniques are there. Otherwise, it can create the soil and water contamination, right? As well as it can help to breed the vectors like mosquitoes, the disease vectors. Industrial wastewater management. So before release, the industrial wastewater must meet the national guideline values, as well as for any project to run for an industry, preliminary step must be needed according to Environment Impact Assessment, EIA.
Ma'am, what is Environment Impact Assessment?
By this EIA, by this assessment, we can predict the consequence to the environment, maybe positive or negative. Runoff management. So if we cannot control the drain, storm drain, etc., so it can create flood, so that can damage households as well as it can generate waterborne diseases, problem to the irrigation, right? So in the town we have storm drain canal, right? But in case of rural areas, pre-planning must be needed, otherwise it can create flood, waterborne disease, etc. So disease may be outbreak. So routes to be identified, location of the routes and channelizing them. Sanitation management, we have to choose the proper sanitation management because so many different techniques are there. So collaboration and installation of the proper sanitation system is needed. liquid waste treatment. It will include the reasons to treat, issues, process guidelines, treatment or techniques, disposal, use, recycling, as well as effects. First one, reasons why we need to treat them, because to protect the water quality, as well as to rise the water demand, as well as the increasing value of the water level. So it will need the permit and the regulation as well. Wastewater treatment issues. So some regulatory governing bodies are there, like Ministry of Environment and Forestry, as well as Central Pollution Control Board. It will give you the water effluent limit. So it will be maintained by modeling and monitoring system, as well as sludge digestion, implementation, that is also very much needed here. Process guideline. Now the treatment process, the system must be simple to operate and maintain. It will be effective and flexible as well. So that may include the biological, aerobic, anaerobic treatment. It will not produce any odor as well. So after treatment, the sewage can be needed, the treated sewage can be needed for the irrigation as well. Sludge can be taken as the manure. Treatment. So two basic approaches are there for the treatment. One, to reuse the waste from the as resource, as well as to resist the pollution. So for that, for industrial treatment, wastewater treatment plant WWTP is there, as well as the on-site sewage facility like septic tank OSSF is also there. First one, collection, storage, as well as treatment of liquid waste. So there are different technologies are there, so by which they treat and produce the byproduct, as well as it will vary according to location, resource, as well as type of the waste. Septic tank, it is actually linked to the sanitation system for partial storage, for partial treatment. It is there. Actually we find it in case of town as well. It is underground system, PVC made, inlet and outlet pipe is there. Retention time is 19 hours. So we can input the sanitations over there. Anaerobic biogas reactor or digester. So it will produce sludge and biogas. Sludge is needed for the fertilizer. Biogas is to produce heat and electrical energy. So in rural families they are used. It is also underground. But here we can find the inlet. So human excreta will be taken as inputs, and two outlets are there for biogas as well as sludge. Fine. And sometimes the animal manure as well as vegetation can be given as the input. Centralized treatment. So you all know that in large town and cities, sewerage system, they actually collect the sewage and sullage, right? And they actually can convey to the treatment plant. Small diameter sewers, they will collect the sewage as well as sullage from the different households. But in case of industrial waste, different special treatment is needed. Pre-treatment rather. Techniques used for municipal and industrial wastewater treatment, mainly first the preliminary physical treatment, screening, filtration, as well as sedimentation and all. Now primary chemical treatment includes coagulation, precipitation, neutralization and oxidation. Secondary biological treatment, biodegradation, bioremoval, bioscrubber. Actually two processes are there according to attached growth system and suspended growth system, either aerobic or anaerobic. You can find the tertiary treatment by nitrogen removal as well as ozone treatment. So aerobic treatment may be natural oxidation pond or attached growth including trickling filter bed. Suspended growth includes the activated sludge process. Anaerobic treatment, anaerobic legume is there. Anaerobic attached growth is anaerobic fixed film reactor. Otherwise, in case of suspended growth, you can follow UASB, sludge blanket with the granular growth, or EGSB, expanded granular sludge bed system. Alternate techniques, you can find there are so many alternate techniques are there: food and beverage distraction, anaerobic treatment, temporary storage, as well as deep well injection and liquid solidification. Disposal. So sewerage is there to carry the sewage, and storm drain carry the runoff. Okay, ultimately they will meet at the sewerage network and ultimately they will dispose to the watershed. There are local technologies, local regulations are there for local disposal, and before disposal dilution is needed, and it is needed for the sanitary landfill reuse. So that particular water can be used for drinking purpose, for industry, for cooling towers, as well as agriculture for irrigation. Recycling. So the corporate demand is going up. To meet that demand, reduction of that demand as well as zero liquid discharge, we need the recycling. Fine. So separating, recovering, as well as reusing by incineration method. Effects of treatment. If it is not properly treated, so that can create health hazards as well as irrigation water problem, because it will contain so many chemical and biological pollutants. So ultimately there is an institute called International Water Management Institute. They assess and reduce the risk for the waterborne disease and water for the irrigation. Water resource management. What is water resource? Significance, conservation and water cycle. Water resource management. It is the activity of planning, developing, distributing, managing of optimum use of water. It includes water cycle management as well as planning of use and demand. A balance must be there. So water resources include maximum use in agriculture as well as managing water for the urban setting and future water resources. So significance, it must include the techno-financial feasibility, sustainability. The strategy include rainwater harvesting, very important, as well as proper maintenance. People's participation is needed. For raw water treatment, so many different technologies, treatment techniques are evolved. Water resource conservation. So how can we conserve the water resources? Wasteland development, construction of wasteland. So by constructing wasteland, runoff can be managed. Okay. Watershed management as well as river valley project. Water cycle. So water cycle is called hydrological cycle as well. It is the continuous movement of the water on, above or below the surface of the earth. Okay. So so water can move from one reservoir to another, like from river to ocean. And it follows some of the physical processes. What are they? Like evaporation, condensation, runoff, as well as precipitation, infiltration, snow melting, etc. Application. So application of what? So here you can learn that somehow some solid can be transformed to the liquid to dispose, but sometimes some liquid can also be transformed. So from there the particulate matter can be concentrated as activated sludge by activated sludge method. So they become the solid waste. So that particular solid waste can be digested either by incineration or composting. So they have several use, like in case of agriculture, like potato, tomato, in some cases for irrigation purpose as well, for other purpose, that particular sludge, they can be used as fertilizer. For horticulture they are used. They have use in erosion control as well as they have some other special cases of application. So students, I have described about wastewater management techniques as well as resource water management techniques. Thank you.